Okay, lecture 15. The reason there is no lecture 14 is because we have midterms that time. So that's why you will not see the lecture 14 as a slide. One important change that office hour now by emails. I'll still be available at 1 p.m. on Wednesday, but just send me emails because the reason is nowadays it will be mostly project-based office hours. So I'll be meeting, or at least I expect to meet each teams more frequently than before. So that's why it's anyways going to be by emails. But if you wanted to meet just in general, you can always send me an email that you wanted to drop by at 1 p.m. That time that I always fix, 1 p.m. Wednesday. Normally I fix that time, not anything else. But you don't have to be that time. Just send me an email as a team. I can meet any other time. Due dates, as I said, quiz 4 is still there, which will be on week 9. And that's after, including everything after the everything that is not part of the midterms is going to be quiz 4. So which will be starting from permeable payments, this class, and there is another class. Okay, so those three lectures will be on I think lecture number 12, then 15 and 16, mostly on the quiz number 4, which will be on week 9. And again, that's not best of 3 quizzes. So that means, whatever your best 3 quiz, I'll use those. So if you did very poorly on quiz 4 or you miss it, you're still not going to be affected that much because I'll count your first 3 quizzes. But if you did poorly in any of those quizzes, this is your chance to improve it. Homework 5 is not graded. The reason I created homework 5 is basically one question where you will learn how to actually do use unit hydrograph to create a runoff um, runoff for a particular point, because that's something you'll do for anywhere you go. You'll use software to do it, and I don't think we learn it properly. So that's why I want to solve that one question. So we'll solve that next class, in class, and then you will try another example on your own using Excel. So this will be all Excel. Okay, so you'll not use any you'll not type anything. Just use Excel. You change the value, you'll put all those different questions. So this will be basically unit hydrograph. So what you'll do is you have a rainfall patterns on any locations. You will use your rainfall patterns to translate to runoff based on unit hydrograph for that location. Okay. And then everything is related to project. So it's almost writing. As I said, this week you will be sending us at least the methodology, not conclusion. You have written introduction. At least methodology means what's your site, what's the description of your site, if you have a site. But if you have any other things, you are just describing that what you are planning to do. And then by end of this week or next week, not next week, by next Tuesday, you will have almost your complete draft to some extent written, so we can check that and give you feedback, which will give you some time to work on your PowerPoints. So that's something you'll present in the last week. So that's why it's very important that you start creating that. It's going to be 10 to 15 slides because you'll talk 10 minutes or something. So obviously it depends on the content in the slides. You can present 20 slides in 10 minutes if it is just pictures and nothing else. So I want you guys to start thinking about it as soon as you create a draft, at least rough draft um, of your project. And TA so far has been evaluating or just giving you feedback. I'll get to that. That's why I say I'll be more involved from this week for your project. So send the links to TA and CC me all the time. I am discussing with the TA on that. And so,
Professor,
yeah.
for the homework 5, what do you mean by not graded but 100% credit?
Oh, I'm sorry. Not graded for accuracy. So you just have to try it on your Excel file. We'll give you template. Uh, you you'll have a different rainfall patterns. I'll give you specifically what patterns you want to choose. You just change number, you'll get in. You'll just do by yourself. So that means we are not going to check it, but
Okay.
you got to submit it to get the. It's like I want you guys to try. Okay, that's all I mean.
Okay. Thank you.
That's just Excel file. The problem will be given. You'll change different variables and you will see how that changes. So we'll solve it in the class and not share the Excel file until you try it. Because once I share the Excel file, you'll just change the number, you'll get the answer, right? So I want you guys to try just what we do in the class. Okay, so all right, so that's all for the what's the rest of the quarter would look like. Mostly we'll learn different types of green infrastructures and how they're designed, but mostly it's a project-based classes. So today we are going to learn about green roof. Last class, long time ago, we learned about um, permeable pavements. The idea of permeable pavements is that it doesn't require any more space than you already planned, because you always have pavements. Same thing, green roof is the same case. You will always have roof. If you have a roof, that means you have space. So you are going to use the existing infrastructures to design green infrastructure. But the challenge is, why not we have green roof everywhere? I mean, every building has a roof, so why not make it green? Well, there is some constraint. That's what you are going to learn in this class. First of all, every roof will not be translated to green roof, because green roof means extra weight. That weight has to be, that the structure has to support that extra weight. That's the first constraint. Number two constraint is the cost, because it's not cheap. When anytime you change something, you are not really using it. You are just changing the roof structure. You're not creating a space for yourself to add another room or something that give you value. So a lot of times green roof has almost not enough return unless you are using it for some purpose like energy saving. So one of the things that you learn here is how to design the green roof such a way that it save you energy for cooling or heat energy. For instance, in Los Angeles, in summer it's extremely hot, at least inside, not here, but now towards the, if you go to a little bit inland towards riverside or those locations or valley, you'll see high heat. And those places you'll put green roof, your cooling bill will be a lot less. Okay, so that's how you can recover some of the cost. Um, so that's the thing, because you're not really treating stormwater using green roof. It's mostly, in this case, in Los Angeles or dry climate, it's mostly energy saving. But if you are from New York, your option is not about energy. Well, it does have some energy in winter, but it doesn't mean that that's the only reason. You can actually benefit by retaining some stormwater and lowering that peak flow, so that you will not have this combined sewage overflow. So that's why I say, it's mostly water quality or energy benefit, or water quantity or energy benefit. So the fundamental reason how you design green roof is based on this graph. Okay, so that's the only thing that you wanted to know. So let's see how many of you have ever seen a graph like that, and it's called water retention graph. Have you ever saw a graph like this, or have you thought of this graph? What does that mean even? So yes or no, you have two choices, A or B. So choose one of them. It's a water retention curve. That's what it's called. Okay. X-axis is moisture content or water content. Y-axis is, I would just say, suction or negative pressure. Another way to you can call capillary pressure. All right, so we have um, close the poll in few seconds. So yes or no answer, whatever you decide. Okay, so if you see that most of you didn't see this one, so let's understand it. Why it is relevant for green roof? Um, as you see, what that means is that the 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 soil or the filter media or the media that you put on the green roof, it will retain water um, based on the amount of water is retained at different dry conditions. So think of this way: when you have a green roof or you put the soil outside, let's say you have a pot of soil and you put some plant on that, and you are growing plant, and you don't water at all. So what will happen in the soil? It will evaporate, right? The water will start evaporating. So first, the water that is in the large pore will evaporate because nothing will holding them. But the water that is inside the very small pore that's held by capillary, they will not evaporate very easily. So what happens is those water is held by certain pressure, that negative pressure that like somebody is holding it. That's the pressure on y-axis. So what it means that if you keep drying, how much amount of water will remain, okay, in that medium. What you want is a medium which retain more water, because if it retain less water, what will happen is that the plants will not have enough water to survive. Okay, so that's the case for sand. So in sand, if you apply a little bit pressure, you lose water as quickly as possible. So if you negative pressure, you drain them, you lose very quickly a lot of water. So that's why you see um, in a sand medium, this is the sand. Okay, so that means if you apply pressure, you drain water very quickly. Okay, so that's why it means negative pressure, that I keep applying more and more vacuum, you lose water as quickly as possible. So this is, let's say this is high water content. As you increase pressure or you shock it, it will come out. Um, and there will be very small amount of water remaining in the system. Whereas in green roof, what you want is you want something like this. Okay, so there, what it means that if you have lots of water, let's say 60% filled with water, that's what it means. 60% of pore filled with water. As you decrease pressure, even you are applying a lot of vacuum, you are not able to take a lot of those water out. And so those are basically happen if the capillary is so strong that is holding that water. So there are two extreme cases. One doesn't hold any water for plant, another hold lots of water for the, or at least you hold lots of water, whether it's available for plants or different story. So usually if this is sand, this is for sand, this is for clay. Okay. So that means you need something in between, because if it holds a lot of water, that means it's so high capillary that plants may not be able to take it. So that's usually case for clay. And there is a negative side effect. If it holds a lot of water, usually the particle size are so small, the hydraulic conductivity is also very small. And you know that many of the stormwater treatment system, you have to design such a way that it will infiltrate water quickly, right? It hold water, but it also should infiltrate. So you don't want the other side of it too. So that's why whenever there is a golf course or let's say green roof, the design component is usually the media filters. What's the particle size that you want to keep, so that you don't continue to irrigate. You hold enough water, but you have also some water leaving the system quickly, so that it doesn't pond that much. So that's the design of green roof. So that's the physics or chemist, not that's the physics or science behind green roof turf design. So let's look at all those different aspect of it. So you have different layer. So let's start thinking of what each layer does. Okay. So let's start with from not from bottom to top down. Let's start from the bottom to top, because that's how the green roof is designed. Okay. So let's start thinking of what does that mean even. So you have a roof. Okay. Um, Roof that is here. So that this is roof. Okay. This is all roof. This is roof. And um, the First you want to do is add a structural support. Structural support is needed because you want to put green roof, but you don't want to directly put on your roof because it will damage your roof. So you don't want to damage the roof first. So that's why you have to put some kind of in between layer so that not only it hold the green roof above, but also it will protect your actual roof, because once it damages, very expensive to rebuild any roof. Okay, so that's the reason for structural support. It protect roof from physical damage. Okay, physical. And also it gives you a basic, uniform surface for things to install on the top. Okay, so let's think of what's the next one. Then you have a roofing membrane. Anybody guess why the roofing membrane is there? If you don't have that one, what will happen?
Could water reach the structural support?
Exactly. So the structural support usually is not something that you don't want the water to get in, because once the water get in there, it will stay there, and it will also damage the biofilm will form, the cement will crack, all those things will happen. So you don't want the water to stay there all the time, and also the root, all the things that doesn't want, you don't want them to go into there. So that's why the first thing you want to do is, this is mostly to prevent water to damage the roof. So this is mostly prevent water. Okay. Okay. So that's for the second one. Okay. The third one, membrane protection or roof barrier. So that's the next, the green one that you see over here. That's already says what that means, because this is basically the black one that you see is a basic high density plastic. It's not nothing else. That's the called geomembrane. That's what is used below the landfill. That's the same thing used below any kind of materials. That's the reason plastic, because plastic doesn't degrade within, let's say, 25 or 30 years. Or normal, this plastic will not degrade for 100 years. So that's why you put this high density polyethylene or SDPE or very high density plastics, strong plastic there. But you don't want those plastic, no matter how the plastics are, if the roots start growing, the the plant itself release chemical that could also start damaging, weaken that plastic structures. So you don't want the root to get there. Okay, so that's the reason you want to add another membrane on top of that to protect the root not to get in there. Okay, so that is basically, this is the membrane protection or root barrier. That's the third one, because any plastic over time will accelerate degrade if there are roots there. Then on the top of that, you have a insulation system. Insulation system is needed if you want to cool your, if you want to use green roof for for energy saving. So that's why you need the, so it's insulation means it's mostly for heat. Okay, it's not for water. Water can pass through it. So this is for heat or air conditioning. Okay. So now you are doing is putting this different type of mat. Okay, that's all you are doing so far. So the next thing is you have to let's see what's going on here. Okay, there's some disconnection, so now you should be able to see my screen. So the next step is basically you have a, a drainage system where any water that comes in from the roof, you want to collect that and drain it out. Okay, so that's why you need some kind of drainage network. And that's what it is there. Next one, the what you see over here is just basically plastic graded one. So you just spread it, or you can apply gravel, right? That's what you do in biofilters or any other system. But just think of this way: anything you apply here on the roof, lightweight is important factors. You don't want to have heavy weight. That's the reason you are not putting gravel here. Okay, all you are putting is a plastic which has porous structure that will just drain water. That's all you are doing. So that's why you're not putting. So basically, it's just for drainage, and this is it has to be lightweight and highly spacious. So this also is very helpful for the plant to survive longer, because if you have moisture there, those moisture will also evaporates, or it will by capillary it will be driven into the soil medium. So the more retention of water in the system is more like a less irrigation in your green roof. Then on top of that, you have another membrane that doesn't show here. This membrane, I'm just going to write it here. This membrane is to prevent growth media to clog drainage layer. Because if you don't put something like that, the soil that you put is going to just fall into that plastic uh, cups. Okay, so that's why you put that one. On top of that, you have basically soil or growth medium. You can put soil, but most of the time people don't put just soil, because soils are very heavy too. So they mix with the lightweight mulch or compost, or sometimes there are different kind of stuffs they mix. They put geolite, they put different types of materials together so that it's become growth media, but it's very light. Something that you might use for aquaculture, or some kind of you might use that for a hanging garden. So that's the same thing, you put it here, and then on top of that you grow your plants. So that's how you design green roof. There is no other process. So the only things that you can change design is that growth medium. So the growth medium size depends on whether you have, because that's the one part which is very heavy compared to any other structures that you see. The insulation is basically foam. Okay, that's you can buy from Home Depot. That's exactly how they look like. Okay, the pink foam and membrane, plastic. These are the stuff not that heavy. The things that is really heavy, or the thickness, is depends on that growth medium. That would contribute to most of the weight of the green roof. And so the only design factors over there is what kind of materials you put it, what's the pore size, because that will determine how much water it will retain. And so particle size, so growth medium, the only way you can control growth medium, you will control the depth. So first is depth. So that is one thing. So you wanted to increase the depth. So let's say this is high. If you are living in Los Angeles, that's where you put the growth medium much higher. The reason is it retains so much water, or the root structure will get a lot of water from deeper soil, so that you don't have to continue to irrigate. So this is depth is high if you have a dry conditions, but if it's depth is low if it is wet conditions. The reason is you don't need irrigations. You just let the water comes quickly, just filter out and just leave the system as quickly as possible. So irrigation is not a factor. And then second is particle size or grain size. If you use too much sand, obviously the soil will it's too heavy. Number one, sand is heavier because it is not porous, and it's also doesn't retain much water. So you want to add mixture of like mulch. Think of you add a lot of mulch there, it will just soak a lot of water, and so that's what you want. Okay. So this is the examples. This is the two examples in Getty Museum on the right side. We that's closed right now, but if you ever once it's open up after Corona, You can see those locations. That's entirely green roof. On the left side is, I think it's a museum in near Los Angeles. I forgot what's the name. But if you've been there, you can see there are different layers when it's like a gradient. In the when the roof is like a high slope, it's very difficult to design anything there. So what you do is you create in different layers. So that's what happens here. The other one is just a flat surface. And I think this is Getty Museum. I don't want to just ask. This is a Holocaust museums too on the right side. So that where people are walking is actually green roof. Everything below is the museums. And you can see in the UCLA, the football stadium is basically a roof. Below it is parking lot, right? So you can create this kind of structures anywhere. Um, so the fundamental process, I explain it. Couple of things we just want to revisit that you already learned. This is a supplying concept here. Couple of things you have to try is the first is the plant health. It's a green roof, it has to look green, right? So the how to increase plant health or improve plant health, that's based on the moisture, nothing else. You add the compost, all that stuff, so that it has enough nutrients, so that's already there. But it's just the how much water it need is going to detect, uh, because naturally there is no other groundwater here. It's everything that's irrigated or rainfall. So water storage is important. So that's why you have this drainage system, aeration system that you can continue to use and irrigate. Um, and very few times people actually use for rainwater harvesting as a green roof, because believe it or not, green roof actually contaminate more water than actually saving it. The reason is you add this growth medium which has lots of nutrients. So that's why most of the storm water that comes from green roof has lots of nutrients. So if you have an area where nutrients is a problem, actually green roof may not solve it. And to solve it, you have to apply slow release fertilizers where the nutrients will stay there, not washed off. Okay, so that's one aspect of it. And second, many of the green roof has heavy metal pollutions. The reason is the rooftop, all that other aspect. Sometimes those, there are metals on the roof. You want to protect those. You don't want to have a green roof on a metallic structures. Okay, that's something to think about. And the number one control is hydraulic conductivity. You already know how to use that using Darcy's law. The only thing I want to suggest is the K. That's the controlling factors. And the what controls the K is basically your particle size. So I'm just going to write this. You know that. So you want to drain it, but same time you want to also retain. So it's usually a mixture of large grain particles and like mulch, small particles. Combination of those mixture will be useful. Um, so these are things, again, I didn't write those. Why porosity is important is basically porous structure. That's where water moves, right? So um, and the second thing, first is drainage. You got to drain so that it's heavy rain, it doesn't flood the entire roof. You don't want the things to retain too long. Um, and second one is water retention. And this is the exactly why it is important, because water retention is key for the plant health, because you are not going to irrigate all the time. So that means if your soil is not retaining that much, your plant will die. Uh, that's the reason in Los Angeles area, your green roof, the medium is very large. And that way the water will stay in the soil at least some extent, and then the root will penetrate that locations and continue to receive that water. So for water retention, if you increase the particle size, opposite thing will happen. In hydraulic conductivity, if the particle size increases, your K increases. Okay, hydraulic conductivity increases, but your water retention or the theta decreases. Water content, also retention. But if your particle size decreases, your K decreases, but your theta increases. So this is, let's say, clay opposite end clay, and this is, let's say, gravel. So when you are thinking of what kind of size you want to use the in between. So ideally, that's why people use biochar. The reason is biochar is bulky, but it has so much internal force that those where water stays. Okay, the outside water will flow around. So that's kind of a mixture that is useful. Surface property of water may affect water retention. So that's something, you know, that's basically surface tension, right? So if you're the reason why water stays in a capillary is because of surface tension. If you decrease the surface tension, they will not stick you; they will just fall off. So that means if you have salty water, it has a different surface tension than non-salty water. But it's not really a lot of changes in real world, so you don't have to worry about that. So water retention, that's why I say the clay retain a lot of water, whereas sand doesn't. That's why most of the time you will mix together. For green roof, you will not use sand or you will not use clay. If you use clay, entire green roof will be flooded. You will not have any drainage. If you use all the sand, green roof will not flood ever, but no plant will survive. So that's why most of the time the ideal component is loam. So 99% stormwater treatment system, if they ask you what kind of soil you use, you'll always hear this word loam, loamy soil, sandy loam. This kind of soil is used. The reason is this. Okay. And so there are two other aspects of it now, why it is important. So the in water retention, within this pressure, -1 bar to 0.033, basically this is the pressure of a medium. If you apply that pressure, that's basically gravity drainage. So if you take any soil or mixture and open the valve at the bottom, let's say it's connected, water will drain because of gravity, and whatever the water remain in the system after gravity drainage is field capacity. So what does that mean? It represent every time it rain, once the rain stop, you will stop seeing any drainage from the green roof, and whatever the water remain there in the system is called field capacity. That's useful for to see how much water is available for plants to uptake later. Okay, and that's also how much amount of runoff that being not used as a runoff because you are holding that water for a while. Okay, so that's abstraction. But if you keep drying the soil or you apply pressure, when you apply high temperature, water will release, the capillary will increase. That's exactly the pressure. So as the pressure increases between -10 to -30 is very high. At that pressure, whatever the water remains, that's called wilting point. That means at that point, whatever water remaining, plant cannot take it anymore. That's why they start wilting. Means the roof, the leaves will start wilt. I don't know what's the other way to say it. It's basically it becomes shaggy and it will fall off. Okay, so that's the wilting point. So every water in between here is plant available water. Everything beyond that one, before that it will drain by gravity. Everything above it, it will just soil hold it, but plant will not use it. So you wanted to have as much water in that system. So that's why, as I said, loamy soil has more and it also drain water. So that's the reason it is being used. So these are the two definitions. Every time you create a soil media mixture, people measure for field capacity as well as wilting point. If your wilting point is during wilting point or you apply that pressure -10 to -30, you will see how much water is drained. That's based on will tell you whether this is a good medium or not. Um, Another thing to think of is compactions. Compaction, if you when you apply this media on the green roof, you might accidentally compact them because if you walk on that, that's another thing that you have to check because when you apply compaction, what will happen is your water content at high pressure is decreasing. So this is compacted soil. That means, let's say this is 60%, this is 40%. I'm just throwing a number here. I don't know what does that mean because it actual number is not given. What that means is if you apply compaction, the maximum amount of water that can retain during gravity drainage is going to decrease because there are less pore space. You are compacting, there is not enough pore space to hold that water. So that's why your soil will not retain that much water for your plant. That's why compaction is not recommended for green roof. And why you should compact, or why people even compact? They don't compact by default, they accidentally compact by walking on it. So a lot of times in green roof you'll see there is this designated walk path where people walk, and there are space where the plants are there. They will not, they will write there, don't step on it. So they put this kind of big rocks sometimes so that you can step on those rocks and walk to access different locations, so that you don't uniformly compact everything. So that's the design. You can see that in the, when you walk on a green roof, this is the reason, science behind it. Again, water retention, this is basically says how much time it takes before it start ponding. Okay, yeah. So that is a function of rainfall intensity. So if your rainfall intensity, so what you want to see is what is that equation conceptually means. Okay, so ponding time, first of all, you don't need, you want it to take long time to pond. Okay, because you don't want the ponding time will be short. So your original goal for ponding time will be as long as possible. That means your green roof is not going to be ponded and not create mosquitoes. So how do you do that? Let's think of conceptually. Increasing, so first K. If K increases, TP increases. What is K? K is hydraulic conductivity. So if you have a highly hydraulic conductivity filter media, all it means that things are drained so quickly that is not ponding. So that makes sense. If you have a high conducting medium, you'll not pond. The next one is delta theta. It means that how much moisture is already filled in those pores in the filter media or the um, green roof media. So if you already feel like if rain just recently and everything is already irrigated, that means if you apply, that means it takes less rainfall to become ponded. Okay, so that difference in moisture content or how much amount of pore space is filled with water. The last one, or this one, is this is capillary pressure. So it says suction head, which is basically, it means in how dry it is. If it is too dry, the first drop of raindrop is going to soak inside it. So it's not going to become ponded quickly because it has to fill a lot of. Uh, so if the capillary pressure is high, that means it's so dry that it will absorb most of the moisture. It will not pond it. Okay. Then there are a couple of other things. Is I. I is rainfall intensity. If it rains so heavily, obviously it's going to pond very quickly, right? Because you are delivering so much water so quickly that it doesn't drain as quickly. So that's why if your rainfall intensity increases, your ponding time will decrease. Or if your rainfall intensity decreases, it doesn't rain that much, then obviously it will take longer time to pond. The last one is difference between rainfall intensity and K. So what does that mean? It means the relative difference between rainfall intensity and your capacity to drain the media. So if your rainfall intensity is so low that anything it drops, everything is drained out, then you'll never pond. Okay, that's the whole idea. So that means if your I is equal to K, the time become infinity. That means you will never pond. Every drop you put is going to drain out so quickly. Only times if the rainfall intensity is more than hydraulic conductivity, then only ponding is a factor. So that's the whole idea of this term, to make sure that this infinity factors come in. So as long as you understand this, basically you understand the quiz questions or the design. So now we are going to discuss the design. I'll just give you a specific number. As I said, the components are, the number one is the weight, because many structure cannot survive that extra load. So you just have to know what's the typical weight of green roof. So that range between 20 to 20 pounds per square feet. So when you think of which structure to put, you just have to see the building specification, whether that can actually retain this much structure, this much load. If it's not, then you will never use it. And this is particularly important in Los Angeles because your buildings are designed for earthquake um, system. So any extra weight will also make it vulnerable for earthquake, right? So you wanted to check that extra factor. That's one of the reason many building in Los Angeles will not have green roof, partly because for structurally they are not probably um, strong enough to hold a green roof. And second, obviously, the cost of energy. Okay, so because you'll spend so much money here, you have to irrigate them to maintain it. You're not really, you're it costs you to maintain them because of irrigations. Uh, the only way you can get some money back is because of the money you save for energy. And usually these green roofs are very profitable for large roof. Okay, large roof like let's say um, think of Walmart or think of all these big retail store. They have a humongous roof, right? So those roof, if they create green roof, they will save a lot more energy because they have to continuously a large operation. So they make the door open. So all the time they have to air condition that system. So if they have a green roof, not only they can grow plants and urban vegetables or other things, or they could also have the energy bill lower because it's very difficult to design air conditioning for a large system which has completely open. Um, so that's the purpose. You see these green roofs are usually for the large one-story building. So there are different design permit, how it is done in Los Angeles. This is written here. Um, all I want to say is that you have to consult with LA County just to see whether you have to do intensive or extensive roof. Intensive, extensive is all about what's the size of um, the filter media or the growth media. And then also Los Angeles County will tell you if the structural it is a support, you can support that green roof. And then fire department also check because if the green roof isn't properly not maintained, it's a fire hazard. Any kind of plant on the roof is going to catch fire, right? So that's why fire department comes in here. And then they have to do the assessment, and then you'll have those teams. So this is the difference, okay? Extensive or intensive, all that. So as I said, you have different types. The difference between the left based on the depth, okay? So this is for dry place. This is for wet climate or dry climate. And again, the reason is the roof will have more water accessibility so that you don't have to irrigate. Okay. And the second one is about drainage type. So as you see, there are many different ways. This is very common plastic one. The other one, you just mix with the sand. So this is basically a wedge. What the wedge does is, let's say you have a wedge like this. So water will stay here. Okay. That's the reason you have this wedge. So that you just create this structure where water will pond. And if you don't have a wedge, this will just drain uniformly. So it will create this block like a pothole to keep it. And then there are different type of mat, the size. It doesn't really matter, just uh, based on the location, what kind of media you use. Right now, it's more common to just use a plastic tarp. And soil properties, as I said, it has to retain enough water for the plants, yet it has to be highly conducting so that it drain the water as soon as possible. So this is the other factors is given. So you can see there are some nutrients you have to add because you don't apply fertilizer all the time. So that's why there are some nutrients is added. And there's other factors is there. Um, Plant properties, most of the time people use whatever they want, but normally it's better to use plant drought tolerant plant in Los Angeles because you don't want things to be irrigated a lot. Drought tolerant plant, it may be invasive or it may not be invasive because you are maintaining within the one boundary zone. So invasive is okay because it's very low chance for them to distribute. But who knows if their seed will go somewhere else. But people put mostly aesthetic purpose. They don't really put native plants. But as long as drought tolerant, that's important. Planting method, as I said, there are different ways you can put the vegetations. Whether you put as a small box, as you see over here, this is the media. You can see there are gravel things that to collect water or just walk above it. All those places are there so that you have pathways. Um, Designing green roof, I just want to show that these are the different membrane. We discussed that already. What are the filter fabric? This is just written here. Okay, what material it is? It's just I wrote it here. So I'm going. I think I share the report so that you can read all of this. I already went over through it in sense of what it is made up of and or what's the functions. Um, so I'm not going to explain every detail, just know that different waterproofing membrane, for instance, they are all plastic. Okay, the only goal is to prevent water. As long as it prove waterproof or the doesn't get destroyed by water, is durable, that's important. There are many ways to apply it. This just say that you can put a glue and then you put on it, or you can put heat. Just basically put a top, the plastic will melt if you apply heat. That's how you can stick on the roof. These are these are just common sense way. I'm not expecting you to remember any of them. This is just for your project. Okay, if you are writing the projects and you are using any of this, I'm just telling you the concept. The root barrier, the after you put the membrane, there is a root barrier, right? So the root barrier is to protect waterproofing membrane from roots and as well as the weathering, because when you have this high heat freeze the cycle, that will also crack the roof, the the membrane. So if you put this extra root barrier, that will protect that membrane. So this is usually root barrier is also plastic, high density polyethylene plastic. Sometimes it is you also add some kind of nanoparticles, copper hydroxide nanoparticles. The reason is you don't want the biofilm to grow. Okay, so if you see over here, what is the reason? Is to prevent biofilm. It can be PVC, all these plastics. No, it just says what's the size will be maximum 1/4 of an inch. You don't need too much. Okay. The drainage, as I said, is the easiest. Insulation layer, we don't go through it because that's optional. A lot of times you don't need it. If you are, for instance, if you are in Newark, well, you need it in Newark too because you don't want in the winter time to be too cold. So insulation layer is only for the energy purpose, right? So sometimes you don't need it if you're not taking care of energy. That's basically a foam. But for the drainage and flashing layer, which is the plastic layer, you see, that's just a different patterns. As I said, you can add gravel or the large rock as a drainage layer, but it will be so heavy, right? So that's the reason people don't add it. They put plastics. But there are lighter strength material you can add. And then it has pipe network. Water retention is done um, by by the filter media. So that's where you decrease the size so that it increase water retention. A lot of time you add a biochar so that it has porous structures. Filter mat we didn't discuss about is basically it's a mat that prevent any soil to fall into that drainage layer. It is porous to let the water moves, but not the soil falling into that drainage layer. Um, okay, that's the filter fabric. That's basically the same thing what we discussed. Growth medium, you add nutrients, you add water, please. Have you water, please? You need 5 minutes. 5 minutes. Yes, 5 minutes. All right, let me give him water. Sorry about that. I'll pause. Okay, so growing medium is again, as you see, this the primary condition. It has to retain water and enough hydraulic conductivity so that it drain it as quickly possible too when it's heavy rainfall. And its primary role is to protect or help the plant grow. Okay, so it should have nutrients, and it should be also lightweight because that's the heaviest part of the green roof design. Okay, so that's why mulch and other things are important. Vegetation, we talk about what's the reason behind it, and that's the why it is called green roof, not like any other roof. So those plants has to be active. It should look good. It should not be, it should not be fire hazard. Means if it dries so quickly, that means become a fire hazard for your roof. It should also require less maintenance, means irrigations. Um, it says should be lightweight. You don't want to put a big trees on it. It should be drought resistance. You know that California is going to experience another big drought now. We are middle of a drought now. So that's another thing to decide. Any kind of green, not just green roof, any stormwater treatment system, plant is a big part of it because of these drought conditions here. It should be wind resistance, non-invasive, all that. That's not from common sense. So the last few minutes, I just want to show what we is done. Okay, then we can take a break. So this is what you go. First, put the membrane or the rooftop. You spread it. Okay, and once you spread it, and this could be the waterproof membrane. Okay, and below that you have insulation layer or something to level it in the right space. So this waterproof membrane, once you put this one or the mat, um, you wanted to connect them together so that there is no leak in between. So you apply heat and that edge or glue or any surface so that that edge is kind of peeled. Okay, and then you made these holes. These holes are basically for assessing because you are going to drain water out from the roof to somewhere, right? So that's the drainage there, and then all those other collection system. Then you put this bar. This bar does, it gives you the border so that the soil doesn't slide or doesn't move across. So these are the things you fix on the top of the roof, and then you basically apply those another membrane so that it just basically another layer of materials. Okay, that root protection membrane, or I just give you that basic process, and then you can apply soil. Okay, and so in this case you don't have a drainage layer, but in the other cases you can put a plastic mat first before you apply the drainage layer. So then you apply the soil everywhere, and then you put plant seed, and that's how you grow. Okay, so it's very simple. This one is not really many complicated. The disadvantage of this particular one is that doesn't have a good drainage network. Okay, so you are relying on, you don't need that drainage. That means this is something probably you want to hold on to that water, like in Los Angeles. You don't need that excess drainage quickly. Okay, but then there is another kind of system. So it's a granular drainage where you put this pipe, PVC pipe. Okay, that's the difference. Once you put that mat, you PVC pipe, you make holes so that it collect at different locations. So what it does, it's advantageous because if any places, um, it's basically it's creating a channel at different locations, and in between your soil is kind of retained. There is no advantage disadvantage, but it's the same thing. Okay, that, as you can see. Um, then there is a drainage mat, which is very common, which is the plastic, the one you see in the actual design where the plastic has a lot of gaps. So that's the drainage mat over here. Okay. Then you pour everything else. So the last one is the cost. This is something you might use it for your design. This is the cost for initial, if you have to re-roof or new roof, that's based on different cost. If you have to re-roof it, then you have to put some extra coatings on the roof before you put the green roof. That's why it's a little bit more expensive. But as you can see, the one thing I want you guys to show is the maintenance cost. Okay, maintenance cost is the most expensive part of green roof because that's something you'll invest every year. Okay, design cost is you see $1.35, but if you think of maintenance, you're spending almost $1 for maintaining that green roof per year, right? So it's almost like the design cost. So the actual the material is not that expensive. It's always the design is expensive. So these are the breakdown that you might use it for your project. And the last thing I want to say is let's have this quiz for 5 minutes. What we learned, and then we take a 10-minute break. So let's see. Stop sharing and generate quiz. Okay, so the first question is um, which one of the layer is not required in a green roof? It's not like a mandatory. Everything else is mandatory. There is only one layer which you may not need it every places, but everything else is definitely needed. So which one of them? Filter mat is basically the one that below the the growth medium. Roof membrane is what protects the roof. Drainage layer is what. So the drainage layer is depends. It's sometimes integrated as a soil. Like it the last few slides I saw that it doesn't have a drainage layer. It means that it uniformly drain. That soil that you added is actually the drainage layer. Okay, because I see many people choose those things. So I wanted to make sure. Okay, I'll end the poll now. Share the result. Um, Depends on as you see, insulation is something you don't need all the time. It doesn't serve any purpose other than energy. Okay, and so that's the thing, it's not always there. Everything else is important. Roofing membrane, you have to protect the membrane. Okay, protect the roof. Filter mat, if you don't use it, all the soil will fall into the drainage, clog, destroyed, so you can't use it. Drainage layer, if you don't have a drainage layer, it's going to hold the water and this going to degrade with time. You'll have mosquitoes problem, or you have a stinking problem, all those issues. So there has to be some drainage. Okay, and that's the reason is so insulation is only reason. It's nothing with water. It's more about the energy bill that comes from the outside and inside. That's the exchange stuff. So the answer is B. Next question. If you want to increase water retention in the root zone, what types of, based on size, growing medium you should add? Your your goal is to water retention, right? Let's say, for green roof, which of them you are going to use most likely for water retention? Okay, another 15 seconds. I'll stop the. Okay, so let me show you the results of what you guys chose. So many of you chose C and D, and usually for water retention, the size has to be low. So that means your answer would be between C and D. Okay, so I'm going to, the way the question was asked, either of them is fine. But normally you'll never use clay, because if you use clay, it's going to retain water, but it's going to also not drain at all. So the plant will not survive in a clay soil. It's not easy to grow on a clay soil because even if retain, it doesn't also give plant anything because the wilting point is so high. Just that it holds so much water that not by plant available. So normally the recommendation is this. Okay, so next questions. If you want to increase water drainage, what type of growth medium? So one of the other two, water drainage. Drainage means you don't want to retain, and the hydraulic conductivity has to be high. So which one of them is highly hydraulic conductivity? It's basically the opposite answer of what we gave last time. Okay, you have 20 more seconds to answer. Five more seconds. Okay, all right, so let's see. Okay, so these two will never be the answer because your size of the particles determine hydraulic conductivity. As the size increases, the hydraulic conductivity will increase, and that increase the drainage. So your real answer is between these two. Um, I mean, but normally none of these are used because they are so heavy. You put some kind of light materials. Okay, but the size is higher. That's all right. So that's all in terms of the green roof, and this is the sustainable. This is something you have to think about before you when you design your project. That's why I wrote the questions. The couple of things you have to think when you design your green roof as part of your project is where you get water for irrigations. Because in real or the arid climate like Los Angeles, that's the cost. What kind of plants to use? Because that's basically also irrigation cost. If your plants require so much water, it's not good. How do you save more energy using green roof? So that's something you have to think of. Um, Adding solar panel on top of that, so that to maintain solar panel, you have to add more water because the dust that deposited on solar panel decrease efficiency tremendously. So most of the solar panel every week or every few days you have to add lots of water to clean the dust. So those water can goes to green roof directly. That way you don't have to irrigate them again, and that's used for green roof maintenance. And not only that, if the solar panels are very the efficiency also decrease if it is very hot. Okay, so if you are putting a solar panel on a roof directly, it's so hot that the energy conversion is very low. It's like if your laptop is hot, you don't really, it doesn't function well. So by adding green roof, it locally lower the temperature a few degrees Celsius or Fahrenheit. So that means it improve the solar panel efficiency. And so you use water for others, so that's why it's always help. And then last is what kind of materials that you can use. Usually you look for lighter materials or lightweight materials. Okay. So these are the four ideas that I gave you. Number one, you can irrigate water by using, for instance, gray water. Whatever water you used for washing, you can use the same water for irrigations by just disinfections. Plants basically um, drought tolerant. Another thing, you can grow food. Okay, so that means your garden will be upstairs, so you can basically you don't have a backyard, but that's fine. You have a roof. You can create that. Uh, Third one, put solar panel. So basically, you have a solar panel. Okay, so you have to apply those water will go there and it become irrigation. So this is cleaning cleaning up dust is same as the irrigation of the green roof. So it's the same water as before. You just apply as a irrigation without getting any benefit. Here you are cleaning something. It's like taking your car and washed it on the green roof. that water is going to be reused. And second, the heat is low. So that means the energy conversion will be efficient. Okay. And the other things, the light material, like let's say biochar, charcoal, all these things can use. All right, so I think now that's enough for the green roof. Let's take a break for 10 minutes. When we come back, what we are going to learn is how to capture water from any roof and save it as a rain barrel. So that system is very simple. Is basically you have a pipe and that connects. So that little simple design we'll just discuss very quickly. So let's have a 10-minute break and we'll see you at 5:25. I didn't realize that I was not recording. So what we did is I just show you the handouts that I put on the CCLE, where you can use to read details about both green roof as well as rainwater harvesting system. Um, yeah, I also saw that Renette says that you got two for $35 a piece. They were in barrel that normally sell about 170. Oh, that's nice. How big those are, Renette?
They're made out of like, I don't know what the capacity is, but they're made out of like old shipping containers for like massive batches of pickles.
Okay.
So they're not like, the big cistern type. They're just like probably,
Yeah.
I can look it up. I'll pull
Yeah.
it.
No, that's good. So you can post on the campusware so that everybody has access to it, because the chat window will not share too much.
Yeah, I'll share it there too.
Thanks. Okay, so again, these are very common sense. The why we capture and harvest rainwater harvesting system is because rainwater is the cleanest water. It doesn't have that much pollutant. Storm water is polluted because it touched the ground. Okay, so rainwater before it touched the ground. So we want to capture that. So that's the reason it's very easy, because you have the roof, collect the water from the roof. That's the way to go. And the reason we want to capture is because if you see the percentage of water in earth, the fresh water is so low, and many of those waters are wasted. The moment it becomes storm water, the expense goes up, how much expensive it is to treat. So that's why you just capture the roof water. It has less pollutions. It doesn't have that much pollutant yet. Any pollutant from rooftop is because your roof is unclean. So that's why, as long as you maintain a clean roof, you have a better quality water to use. So that's the reason it's very efficient to use rainwater harvesting system. For some reason, the screen is frozen, so I'm um, going to try again. Let me see again, because anything I was doing, I was not seeing the screen moving. Okay, so I already explained rainwater has advantage of less pollutant, and it's very easy to install because already part of the every household you have the gutter system where the water will from the roof will drain into somewhere on the ground. All you have to do is just capture it, reroute it into a barrel. So how it works, you can click on the link, you can see that how they look. I show you before the recording in that handouts. So the benefit is it reduces runoff because it's basically a storage device. It doesn't have any treatment. It reduces water bill because you can use that water for irrigation of your lawn. So that means you don't have to use the traditional water supply. And you can use the rain barrel a lot of times to irrigate the rain garden. So the idea here is that you capture the roof water and then you slowly release that into the lawn as well as your rain garden, so that you don't have to maintain them with normal clean water. And then also so-called, it used to be like this. I don't know whether this is still valid or not. It has $75 rebates on your rain barrel. So maybe that's the one Vinay just said. Um, how much rain you can collect? 1 inch of rain just for 1,000 square feet of roof will equate to 623 gallon. Why it is important? Because normally on average we use 80 to 100 gallon. So if you have 6 person family and you get 1 inch of rainfall that day, you get enough water for the entire day. Okay, so that's your footprint. But normally you don't depend on rainwater to use it. You are basically using for the irrigation or washing your car or other purpose. How to install in LA? This is the YouTube. Somebody was installing. You can see that. Again, I don't want to. So it's the same thing. DGF put a basically you put some kind of container or some kind of balanced surface, then put the barrel, and then basically you direct to the gutter inside it. Okay, there are different ways to design this pipe, how so that it doesn't overflow. So basically you have a system where a pipe here, so that if the water goes above it, it will start draining. Okay, so that's just the so that you don't want to um, things to overflow. So before that, it will start draining outside. So those the designs are there. Decision making is basically, I would say that almost every place you can use your the rainwater harvesting systems. And but normally, what decision where people don't use it is if you do not collect enough water for anything, you are just keeping that, not using it. So in Los Angeles, even though they're giving for free, it doesn't rain much. So you can think of either way. If it doesn't rain much, you are not using it. So it's just sitting there, doing nothing. So it's kind of places where it has to rain to have it rain capture. So that's basically demand and supply. Whatever you invest, you got to get it back by using that water for some way. So you got to have enough demand. So any places where it rain a lot, you don't need rain barrel to protect it because you naturally get all the time rain. So on the other side, it's too dry, you don't need it. In between, you need it. And some places like Colorado, where every rain that comes to your property, you don't have right for that. So that's another water right you have to think about because the water that you receive in Colorado is owned by people in Arizona or California because they depend on it. So that's how the complex water right systems. So some places the policy itself will not allow you to have rain barrel. The process is simple thing. You filter all the leaves and all the large particles out, and any kind of pollutants you may be able to remove by putting activated carbon tank system. But that's if you are going to use that water for drinking, and then you have disinfections. But 90% of rain barrel is mostly debris removal, like remove large leaves and other stuffs. And sometimes you can also put a first plus design. I'll show you how it is done. But a couple of things you want to check is the pH of rainwater. Some places, if you have acid rain, the low pH can dissolve some of the metals from your green roof or from your roof. So you don't want to have a rainwater collecting system if your roof top is made of metals, because that will release a lot of these pollutants. So design, again, these are all in the handout. As I said, your rainwater coming in here, and then you want to have some kind of filter to remove the leaves. You don't want this leaves to get out. And then basically you have in between debris excluder, because even something fall off and goes, you don't want to connect one pipe. You just basically you break the pipe in between and then put another filter, so that it drop into that filter as opposed to directly go. So you have another debris removal. So these are basically filter in both places. The one extra is this one. This is basically I'll show you. This is basically take care of the first flush. design. The idea here is that if I extend it, your pipe comes here, you collect water, but you create a um, um, you basically create a surface where the pipe, any kind of water comes in, the very first flush, whatever the first amount of water that comes from the rooftop, if you retain it here, only when it's completely filled up to here, then water will start moving. So that means that the very first drop of water will be retained here, and it usually has more pollutants because the very first flush has a lot of dust. So you don't want to collect that. So that's how you can create a groove here, the pipe, so that that drop will go there first. Once it's completely filled, the rest of the water will drain into there. So that's the first flush design. This is called first flush removal design. So this is something very common in many places where you don't want to capture that. And what's the volume of whatever the amount can retain here is the basically size of the roof, whatever the first flush volume would be. And as I said, the quality depends on the roof design. So normally you don't want any kind of metal roof. So that's why it's clay. All these roofs are pretty good for the green roof. Don't use roof for untreated metals. So it has to be galvanized ring so that it's not releasing those pollutants. And a lot of times people apply herbicide because you don't want the plant to grow or the weed to grow. So if you are applying those herbicide, don't use that water. Make sure that it's all clean before even you start using. Again, I talk about this joint gutter where you have this basically screen to remove leaves, and then this joint basically here you can have another screen. Sometimes if you want to, the way to do it is basically see the natural way, and you just cut it and just remove that into your rain barrel. And so this is, I already talked about the first flush removal mechanism. This is this example just to show that every initial water will drop all the way to the bottom, and you can have a valve here to open that time to time so that all the dust that accumulate, we can remove it. So this is the first flush design. That's a simple T. That's all it does. And the cistern is basically big tubes or the big, like Renate says, pickle jar or pickle barrel or beer barrel. So this is basically plastic materials. It's coated with inside coated with antibacterial agent so that it doesn't grow biofilm. And sometimes you have to add a little bit bleach so that it doesn't really the biofilm doesn't grow. So those are there. That's it. There is nothing else there to discuss. Again, this is just overflow. And just when you, if it is too much water, you don't want the pressure to break the, not break it, but it's just going to weaken the structure. So you want to have some of the water going out of the system. Once it's completely filled, it's going to not, it has a mechanism to release from the system. So normally these are not treated. So that means you don't use for drinking. What you do is for irrigations or car washing or spray irrigations. Sometimes if you are, sometimes you need to disinfect. That's why you add some bleach or you have a EV disinfector. You can just turn on that EV light in between so that it is maintained. So maintenance is basically cleaning so that there is no biofilm, but it's just the first flush dry water. You have to, this one, you have to basically open this cap time to time so that any dust accumulate will release from the system. It's pretty simple design. There is nothing there to really discuss other than the fact that you have to have a strainer to um, debris. So this is the cost. Not the cost. I didn't write the cost here. The maintenance, and that's it.
Professor,
Yeah.
I had a question. I don't know if this is something that's like very realistic, but I just know that with the like kind of rapid implementation of residential solar, and how utilities are buying back some electricity from from houses, is there any sort of like buyback or any sort of like return or like benefit that maybe like the municipality like would be looking for in like rainwater catchment from houses, or is that just like because it takes so long, that's something that's not really realistic at this point?
So sorry, I was distracted a little bit because somebody called without even realizing I was trying to turn off the
Oh,
phone.
no worries.
So if
So
you
basically
briefly
like,
said, yeah,
yeah. So basically like houses that are producing solar and have excess energy or selling it back to utilities, is there
yeah,
any sort of equivalent to
yeah,
like
to use the
water?
rainwater.
Like,
No,
yeah, I
because
feel like it's
the
just like you can't collect enough for that to be like realistic, right?
yeah. So I think the challenge here, any water treatment system or water is a supply. Not like electricity is very easy to. It's energy, right? So energy is easy to move. Uh,
Right.
uh, but water, moving water costs energy. So energy is the limitations. Even you
Totally.
have that's the whole reason why water cannot be transported very easily. It's not because we have enough water. It's not like we don't have enough water. I mean, New York has more water in 10 years than California would have. So that means, why not we just drain that water from New York to here? That's not true, because that's what we are doing, in fact, in California, Northern California water coming to Southern California. It's not sustainable because up to a
Hmm.
point, the energy is not just too much. So now that's the whole idea of distributing water. You want
Hmm.
to have as much distributed system than centralized system.
Got it. Okay. Thank you.
Um, so I think this is a, um, let's see. Let's see, I was just checking that some question. No, I don't think any other question there. All right, so I think that's all in terms of we learned today about um, green roof as well as rain water harvesting system. And those two systems doesn't require much space, right? Rain barrel requires some space, but you can dig in and put it. So we learn about permeable pavement before exam, now green roof, and this one. So now these three you can apply almost any places, okay, as long as the roof require. For your projects, you don't have information about the building, so that means you can assume that it's possible. So for instance, some of you have discussed about in locations where you want to have green infrastructure, so you can think of some green roof in some of the buildings, or it could be in the school, so that you can have um, those green roof, and students can go up and they can have a garden there. So that's another thing to think about, as long as it's nobody fall from it, so that you have boundary, all that. So these are the three green infrastructure design which can be installed anywhere. Almost the structures are okay. From now on, next class we'll learn about other type of design where you require space. You need to have extra space to actually maintain. So
How
for
would
yeah,
how would the use of rain barrels look like for like a single family unit versus a multiple like family complex?
so I think it's like a water said, what's the catchment, right? So what's the roof where it drain? So that's basically you. If the roofs are designed such a way that you don't collect everything in one place, you just collect wherever it drain. Otherwise, you just have to connect pipe, so much pipe. It's not efficient to connect rerouting pipe. So for instance, if you have like multiple like zigzag roof, then you collect rain barrel in between, so that both way it comes down there, as opposed to one half will go to another rain barrel, another half will go to another. It's easier, cost effective that way, because the pipe network will clog so easily, and also it's harvest lots of pathogens if you stays there like long pipe without vertical. So vertical pipe, water doesn't stay. So that means not biofilm will not develop. But if you have a horizontal pipe, water might stay a little longer, and then you will, all the dust will accumulate. That means you will have pathogens. So those are the system when you have the connected system. We don't want to do that.
So a pipe or a system with like the least amount of horizontal piping and the
Yes. Yeah.
amount of piping in general would be the best.
Yes. Any other question? All right. So I think I'm going to stop recording now.